Welcome. Today we're going to be covering the question, what is the integral of sine cubed 2x multiplied by cos squared of 2x? We're going to be using u-substitution. So let's get started. One of the first things that we need to note is this identity. Sine squared of x plus cos squared of x is equal to 1. And the reason why this is important is because we can see sine cubed of x and sine squared of x. We can be able to write sine cubed 2x as sine squared 2x multiplied by sine of 2x. That's important because whenever we have equations that have to do with powers like cubed or to the power of 2, we always want to make sure that we match. So let's write that down. This integral could be written sine squared 2x multiplied by sine 2x multiplied by cos squared of 2x dx. If we know that sine squared of x plus cos squared of x is equal to 1, how can we rewrite this so that sine squared of x is the subject of the formula? Well, we can say sine squared of x, in this case when it's with x, sine squared of x is equal to 1 minus cos squared of x. And since we have 2 of x over here, we can do the same thing, saying sine squared of 2x is equal to 1 minus cos squared of 2x. So let's write that down. So now that we know that we can write sine squared of 2x being the subject of the formula so that we can have 1 minus cos squared of 2x, we can then substitute the new sine squared of 2x, which would be 1 minus cos squared of 2x over there. But now let's just rewrite this so that it's easier to read and we can group everything together. So I'm going to write cos squared of 2x in the front multiplied by 1 minus cos squared of 2x multiplied by sine 2x dx. So what do we notice? We see the cosines together, so we can distribute that. Cos squared multiplied by 1 would be cos squared of 2x, and then cos squared of 2x multiplied by cos squared of 2x would be minus cos to the power 4 2x. So that would give us cos squared 2x minus cos to the power 4 2x, because whenever we have exponents like cos squared of x multiplied by cos cubed of x, we're going to get cos 5 of x, right? So we just add the exponents multiplied by sine 2x dx. So now we're going to be using u substitution. So let u equal cos of 2x. The reason why we choose cos of 2x to be u is because we want to change it, right? We want this to hypothetically look like u squared minus u4 du. We want it to look something along the lines of that. And so that's why we chose u to be cos of 2x. So that du, which is going to be the derivative, would be equal to minus 2 sine of 2x. Because the derivative of cos is minus sine dx. Making dx the subject of the formula, we're going to get du divided by minus 2 sine 2 of x. And so on the right track, because all we need to do now is substitute the u values, so u cos 2 of x with cos squared of x, 2x, and the dx value, so that give us the integral of u squared, because we said u is equal to cos 2x, minus u to the power of 4 multiplied by sine 2x, which would be multiplied by our new dx, which is then going to be du divided by minus 2 sine 2x. And what do we notice? The signs cancel each other out, and so that's going to give us minus half, which we can be able to rewrite as minus half u squared minus u to the power of 4 du, since the signs cancel each other out. And what do we notice about a scalar is that we can remove it to get minus the half of the integral of u squared minus u to the power of 4 du. But let's just rewrite the half properly, just so that it can be more clear, the 1. What we notice is that we can distribute the du so that we can be able to say minus half integral of u squared du minus the integral of u to the power of 4 du, which then would give us, so that would give us u cubed over 3 minus u to the power of 5 over 5. But we're not yet done, because we still have the u's that we need to substitute back, right? We said that u was equal to cos 2 of x. So now we have to substitute that back in to be able to say minus half. And if u is cos 2 of x, that would be cos cubed 2 of x divided by 3 minus cos to the power of 5 of 2 of x divided by 5. But most importantly, never forget your c plus c. And so that's the final answer. Thanks for watching.